Hey everybody, in this video I'm going to show you how to solve exponential equations using logarithms. So to start off with, you need to know three properties of logs to go through this unit. And you're going to use these throughout the entire logarithm unit. This first one basically tells us if I have a log where my argument is raised to some exponent, I can actually pull that exponent out front as a coefficient. That's super important. You'll see that everywhere. This next one, not as popular, but I do want you to see log base b of b, where b is just some number, is equal to 1. Because this is the same thing as me asking you b to the what power is equal to the b, and that would be 1. B to the first power is just b, right? So that's an important one to know. The last one is called the change of base formula, one of the most important ones as well. So 1 and 3 you're going to see a lot of. If you're given log base b of a, that's equal to log base n of a divided by log base n of b. That seems kind of confusing. N can be anything. That's the important part for this one. We're going to do this a lot when we solve these types of equations. But basically, it's just log of a divided by log of b. As long as the bases are the same, that's how we find the value of whatever this is. Now, I know I'm kind of talking a lot, but I do need to show you what's going on. So how we actually solve these is when you first see your equation, you need to isolate the exponential term. So get it by itself. Once you do that, you want to take the log of both sides. After that, just solve for your variable. Seems pretty straightforward. I know you guys have probably seen the problems. It doesn't look that straightforward, so let's jump right in and I'll show you how we apply these. All right, so this first one, actually, if you look, the exponential term is already isolated, so we don't have to worry about doing anything there. All we're going to do is take the log of both sides. So we do log of 9 to the x equals log of 19. And if you remember, log by itself is the same thing as saying log base 10. We just don't have to write that. That's called the common log. So if you see a log by itself, remember there's an invisible 10 as our base. So that's an x, by the way. Now, we can use that first property that I showed you. 9 is being raised to the x. I can rewrite this as x times log of 9, and that's equal to log of 19. And remember, these values right here, they're just some numbers. We have no idea what they are. They're probably really nasty decimals, but they're just numbers, so we treat them just like anything else. We now want to go to step 3, where we just solve for our variable x. So I'm going to divide, it's being multiplied. I'm going to divide both sides by log of 9. And if you were to go ahead and, let me actually get rid of this. So this is all equal to x. Whoop, I erased everything. Let's try that again. If we can go ahead and get rid of our logs, because these cancel out on the left side, and we're left with x. If you were to put this into your calculator, I erased the 9 too. Wow, I'm all over the place. If we were to plug this into your calculator, you would get roughly, I think it was 1.34. Something like that. So you want to double check and see what they're asking you. If they're asking you for the exact value, then this would be it. If they ask you to round, to the nearest hundredth, that's usually what they'll do. Then you round your answer. It's going to be a nasty decimal to the nearest hundredth. And in this case, again, it's roughly 9.34. But the cool thing is you can check your answer. If I plug in 9 raised to the 1.34, I'll get something that's really, really close to 19. It's not going to be exact because I rounded this value. Okay, but that's pretty much how we solve this one using logarithms. Okay, let's try another example. So again, if you see here, our exponential expression is actually already isolated. There's no coefficient out front. There's no plus 3 that we need to get rid of. We're already it's already isolated, so we can go ahead and take the log of both sides. And you're going to see some expressions in your exponents. That's just kind of how they like to make these a little bit more difficult, but it's still the same process. So if you notice, 2 is being raised to some exponent. We can take that out front using our log property, pull it out front as a coefficient, n minus 1 times log of 2 equals log of 27. And we can still do the same exact thing, n minus 1. It's really tempting to distribute here. I wouldn't do that. Just go ahead and get rid of this log of 2 by dividing. Because it's multiplying, we just do the opposite. Both sides we divide by log of 2, and this would cancel. I keep forgetting to lock these in place so I don't erase everything, but we get rid of the log of 2, and we're left with n minus 1 equals this crazy looking expression. So all we have to do from here is add 1 to both sides, and that will give us n. And I think this one was roughly 5.7. So I accidentally used 26 instead of 27, and it's actually about 5.75. So n is equal to 5.7. And again, this is all based on what your teacher is going to ask you. Round it to the nearest hundredth or tenth or thousandth. Make sure you don't get points taken off for that like I did back in the day. So if we go back and plug this in, if you were to do 2 raised to the power of 5.7 minus 1, that's 4.7, that's roughly 5, and 2 to the 5th power is 32. So it would make sense that 2 to a little bit less than the 5th power would give us a little bit less than 32. So that's a good way to check your answer. Always do that on these ones. And you can kind of see, like, am I off a little bit? Does it kind of make sense? But that's how we would solve this one. So let's try one more. Okay, the last one. I finally gave you something where we have to isolate the exponential expression. So I've got a minus 5 here that I do not want on this left side. We don't want to have to take the log of this whole thing. That's why we isolate the exponential expression. So I'm going to add 5 to both sides. And we get this right here. Now it looks exactly like the other two problems that we did. So let's go ahead and log both sides. Let me move this over. So we're going to log. Let me lock this in place. Log both sides. And we get, again, notice your property. You can pull this out front as a coefficient. And we get 4 times n times log of 3 equals log of 30. So there's a couple things you could do here. I would just pull the n out front. And if you notice, n is being multiplied by this whole thing. You can actually just divide by that whole thing in one fell swoop. 4 times log 3. So 4 times log 3. And if we were to evaluate this, we would get roughly 0.774. So I'll put the little approximate 0.774. So again, if you want to check yourself, you can plug that in for n. And we would say, okay, well, 3 to raised to the power 4 times this, roughly 0.774. And that would be, I don't know, roughly 3-ish, kind of. Minus 5 equals 25. And if you were to evaluate this, you would get, a little bit, this again, because that's a 4, by the way, because I rounded this is going to be a little bit off, but it should be right around 30. It's going to be probably a little bit less than that. But if we subtract 5, we'll get just around 25. So that's how you know it's never going to be exact when we have to round our answer. But that's how you know you got it. When you get 24.999 or 25.000 something, that's how you know that your answer for whatever variable is correct. So again, just to kind of go back, let me move up a bit, just to go back to what the main idea is. Isolate the exponential term, take the log of both sides, and then just solve for whatever your variable is. Now, I know the logarithms get a little bit more difficult. I'll cover those in another video, but I just wanted to give you just a nice primer on how we solve exponential equations with logs, because it looks really crazy when you first see it. But you've got to remember these 3 formulas here. I know we didn't use this one. I put it on there because some teachers do teach it a different way, where we do use this property, and it's basically the same thing. It's just another way of going about it. But you do need to know these 3 properties of logs regardless. Okay, so hopefully this helped a little bit, and we'll see you in the next one.